Manual inspection of rice grains to ensure the quality is a very time-consuming task and labor work. Whenever an expert needs to analyze the rice sample, he has to inspect each rice grain manually. After manual inspection and counting, a detailed summary is generated that evaluates the quality of rice. In Pakistan, rice is the second most important food as well as a cash crop. The potential yield of recommended rice varieties is comparatively higher than the average yield obtained by small farmers. Characterization of rice grains is done by physical inspection of shape and color or rice grain. Depending on the skill of every individual human, information of rice grain arrangement can be lost and unreasonable. For a common person, it's difficult to distinguish a rice type with his/her naked eye. Therefore, traders easily deceive a person. So end customers need a solution that will help them to correctly identify the genus of rice grain with high accuracy. In short, we need to design a cheap, fast and reliable framework for segmentation and classification of rice. So ML Bench started to think about the problem and came up with a combined solution of computer vision and machine learning based techniques that will work into customers' mobile devices. The proposed machine learning based approach will help the user to identify the genus of rice grains. After detailed discussion about the characteristics of rice with the trained staff, we have collected our dataset from different rice factories and local commission agents in Jalalpur and Pindi Bhattian dist. Hafizabad, biggest rice market of Asia. Thousands of rice grains have been captured with iPhone 13 Pro camera of 12 megapixel. After dataset collection, the main task is to annotate each rice grain in images captured. It is very difficult to annotate the data as the instructions are required from the experts to identify the accurate genus. Annotation has been done manually using an online tool called labelbox. An input image used in the proposed solution could contain any number of rice grains in any rotations and any alignments. We used various pre-trained deep learning models to train our dataset. We performed our experiments on ResNet 50 v2. VGG19, VGG16, AlexNet. The highest accuracy we got is by training our data on ResNet 50 v2. Automatic localization and classification of rice grains using mathematical morphological operations and CNN-based approach. We took complete images of rice, annotated them manually using labelBoxExported annotated images in JSON file format, which is very easy to read into the Python code. After that, these images are passed through the combined framework of UNet and watershed algorithm that perform that localization and segmentation task, which as a result extract the individual rice grain from the feeded images. Then these individual rice images are trained on different deep convolutional neural networks that identify the genus of each rice grain. After After that we have extracted these ML models through TensorFlow Lite and integrated them into our app, which now performs the same manual task of classification in a few seconds with high accuracy.